university supported travel. So a lot of this is travel, which is also a challenge because travel is essential to what we do as a university and to our educational goals. So we're going to look at, as we look at each of these scopes, we're going to look at how we're trying to get to neutrality in each of them, especially around some recent developments, both in new buildings as well as in plans that we've done for campus. And I'm going to give sort of the overview, and Lynn, being the expert in energy, is going to get into some of the details of what we're doing and what specifically is happening at different buildings. So we'll talk about a few things that have been going on here in scope 1. So a lot of what we'll be looking at is electrification. So trying to get to electrifying our buildings. And mostly we're talking here about electrification of our heating system. Natural gas is an efficient way to heat buildings. It's a way that we've done it for years. Most of us have this in our homes as well. If you have like a forced air heating system. But it's something that if we're going to get to carbon neutrality, we're going to have to eliminate our use of natural gas or offset that. We're not in a situation that some universities are to go to a combined heat and power. So some universities are burning wood chips or using other types of fuels to heat buildings. That's not something that we're going to be able to do here. So one of the things we're evaluating is how do we electrify our buildings. And this is partly because you may have seen that Xcel, who's our electricity provider, has set in place a plan to reduce the emissions from electrical production to 100% renewable by 2050. That aligns well with our goal of 2050. And you see they're already well on their way. So when we started looking at our carbon footprint in 2005 and 2006, we were in the dirtiest grid in the country. So most carbon intensive grid around. Xcel has made leaps and bounds in terms of getting from a 4% to a 30% carbon free. So if we can electrify the heating in our buildings and even potentially electrify our fleet, we'll be looking at carbon neutral or renewable energy powered heating and transportation due to Xcel's goals. So what we're going to get into next is, as we look at electrification, we just did a big study on converting our campus steam plants. You may or may not know that we have several large boilers in the basement of Sturm. They provide heating to 18 different buildings on campus. And so we looked, and currently they produce steam using natural gas as a fuel, and that steam is then pushed out to other buildings to heat them. You may experience this early in the spring when things get real. They're still staying pretty hot. It's coming through the steam system and into many of our older buildings. So we undertook a campus a study to look at steam to hot water, which would allow us to electrify the system. And really, we're trying to get to improving energy efficiency. We're trying to look at reducing these scope 1 emissions and trying to get to some future planning as to how we address that. So what we're trying to really get to is this little chunk of our central plant scope 1 natural gas fuel use, and that's what this study looks like.
Great, thank you, Chad. So as Chad mentioned, what we'll talk about next is our efforts to reduce our scope 1 emissions, focusing on our central plant and our steam distribution across campus. So we just completed a study. The study was to determine the feasibility of converting from steam to hot water across campus. 3 components to that study. That's looking at the distribution, the buildings themselves, and also the central plant, which resides in the basement of Sturm Hall. So just an overview of our distribution system. It is a low pressure steam system with boilers at Sturm Hall. Only 12 buildings of all of our buildings are served from the steam system. That's about 20% of our building stock across campus. So almost 3 miles of direct buried steam across campus, various isolation valves, shutoff valves as well within the buildings. A key point, and one that really comes into play with the results and the feasibility of switching to hot water is that our distribution system is fairly new, actually. It was all put in the late 90s and early 2000s. So there is 20 plus years of life remaining with the steam system. So just to talk through, it's a tremendous project to make these changes, and just to briefly kind of talk through what transpires. The first thing we would do would be to convert the buildings. We would replace the steam to hot water converters in the buildings with heat exchangers. We would also replace the existing steam heated domestic water heaters to water heaters that would work on a water-to-water basis. As Chad mentioned, the steam system does not only provides heating to the buildings, but also it provides the domestic hot water for the buildings. And then obviously a big part of the project would be to replace the existing steam lines with hot water lines across campus. So the challenge with the project such as this is really keeping all of your utilities in service, being able to provide heat to those buildings as you make these changes. And we would do that in phases. The way we would approach this is we would actually construct a steam to hot water converter, a station like you see here. This is actually one that was used at Stanford when they did their conversion. We would actually be able to move this around as we convert buildings to hot water ready. We'd be able to move this converter around, continue to utilize the steam boilers within Sturm Hall, but provide hot water on a temporary basis to each of the buildings. And then a lot to see here, but basically these were drawings that were developed in order for us to come up with the cost associated with making such a conversion. And in this case, this would be converting the steam boilers within Sturm to either a natural gas hot water generator or electric heat pumps moving forward. So when we compare the systems, let me jump in. Okay, so the steam boilers and distribution, that's our baseline case. That's our business as usual case. The other scenario we looked at was using natural gas hot water generators and hot water distribution across campus. And then also looking at heat pumps and water distribution, which would be an electrified solution. So in all cases, let me just jump here. So fuel cost, I just want to build up this graphic so that you can have an understanding of the operating costs, and then we'll get into the capital cost, which makes a project such as this challenging, at least from an economic standpoint. So what you see here are the natural gas costs, the existing cost. You see here, you see the cost would drop a little bit for natural gas if we were to go with the hot water generators. If we go fully electric, then you see the electrical cost here as well. A little bit of an electric increase with the hot water generators because the pumping requirements are a little bit greater than our existing system that we have. If we continue on, just adding up all of the remaining operating costs, water costs, pretty minimal, pretty similar. Chemical treatment of water, very similar as well. The maintenance of the distribution, not that much different, as well as the maintenance that would be required inside the plant itself. So when we add up all of the operating costs, what we come up with is this number. So currently, we're paying about $278,000 a year. That would go down slightly if we went with the natural gas hot water generator scenario. And then obviously it would go up significantly. It would double our operating costs if we went with the electric solution by using heat pumps. What I want to point out here is the leaf you see there in those values, those are actually the tons of carbon dioxide emissions that each different system produces. So our current system is at 2547. That is the the small piece of pie that we highlighted within scope 1 that we're trying to address. It decreases slightly with the second scenario, and then it also obviously it decreases even more as we go all electric with scenario number 3. What is interesting and what I want to highlight here is this. So the leaves you see here are current, but if we look at the projections for our emissions for the year 2050, which is our goal for carbon neutrality, notice that we have a slight decrease with scenario 2. But if we go all electric, our scope 1 and scope 2 emissions go to 0. So that is a scenario with all of the electric heat pumps that would allow us to reduce scope 1 related to our central plant and steam distribution. Going electric would drop that to 0. So let's look at the capital and what is required for these scenarios. So some costs associated, this is distribution costs, that's really deferred maintenance for our existing system. You can see the roughly just over $5 million for distribution to convert to the hot water scenario. And then this would be the cost associated with modifying each of the buildings, the 12 buildings that are currently on our steam system. And then the plant modification cost as well. So not a inexpensive endeavor. We would be looking at, if we were to go the route of reducing our scope 1 and 2 emissions to 0, we would be just over $28 million in investment to do that. So study findings, the hot water generator case, there is no return on investment, and we compare it to the business as usual case. It is worth noting that the cost for that project on a metric ton carbon dioxide equivalent would be $998 for each of those units of carbon. The heat pump scenario could have a return on investment. Once we factor in the deferred maintenance of our steam system, currently it's possible in the later years, once our steam distribution ages 20 plus years out, that there could be a return on investment. And then you can see that our cost per metric ton drops to $372 for that scenario. So what does the study tell us? Well, it doesn't make economic sense from an operational and a capital investment scenario to invest in making that conversion now. It does make sense to continue to fund and maintain our system as is. It would be valuable for us to actually inventory building loads, not only at the 12 buildings currently served, but also look at the other buildings on campus. It might make sense at some point to add those buildings to the distribution system. Building energy audits, always valuable to understand the building energy use on each of those buildings. And then the other thing we're working on now is to have design standards that support electrified utilities. So we'll talk a little bit later about the new Burwell Center, which is an all-electric building here on campus. But we also want to consider it might not make feasible sense to have an all-electric building with new construction, but we at least want to have the features in place to be able to maybe accommodate that later if we want to make that conversion. And then finally, we want to pursue a study to electrify campus thermal utilities at other locations throughout the university.
Thanks, Lynn. And keep those questions coming if you have them. We'll keep trying to answer them in as timely a manner as possible. Oh, good question on the solar. Way to tee up our next section, whoever asked that. I appreciate your question, anonymous attendee. Okay, so one thing I want you to keep in mind too from Len's presentation there about his discussion on the steam to hot water was that we want to keep in mind that cost per metric ton of carbon dioxide emitted. We're trying to get to carbon neutrality. Those identified costs there were at electrification, $372 per metric ton of carbon dioxide equivalent to make those changes to reduce that amount of carbon from those projects. So if you think back to that pie graph of our total carbon emissions, we're trying to eat that pie in small bites. We want to take slices out of that pie as we go. And we need to plan for doing that over the next several decades. There are ways to jump right to eating the whole pie at once, but I'm not sure if we have the appetite for that yet. We can talk about pie eating later near the end. But we'll look now at this next piece of the pie, the scope 2, which is what we can do for our purchased electricity. And really there's two main things we look at here. One, the most efficient buildings we can build, or the most efficient we can make our buildings, or the most efficient we can operate our buildings is going to take the biggest, cheapest chunk out of scope 2. So the more efficient that the energy that's not used, the energy saved is an energy doesn't cause emissions. Another thing that we can do is utilize renewable energy. And so if you've been paying attention to some of our messaging and some of our roofs these days, over this project's been going on for a little while, but we just have wrapped up putting solar onto 18 roofs across campus. And so here's a good image of some of those. Clearly this image is a little dated since the community commons is not fully finished here. But here you can see a number of these solar panels. So I would encourage you to check out this link off of YouTube. We can share this in the chat perhaps. I'm not going to take I'm going to break something if I try to show this. There's just a good producing energy currently. We're about to take full ownership of that in the next couple of months as they finalize some of the last details. This will produce about 6 to 7% of our total electricity on campus. That meets that 5% goal that we were shooting for. It also will reduce our carbon footprint by 2 to 3%. So maybe 3 to 4. We'll see when it's in full production. And we'll be tracking this. We're working on some dashboards, so you'll be able to see exactly how much electricity is being produced at each building, how much is being used at each building. But this is a good step towards adding renewables onto campus. However, we are landlocked, and so we don't have a lot of options to continue to add. We can't get all of our energy from solar that we add on campus. We'd have to get creative about that. So when we look at solar, we are also, this is a 2.2 megawatt array or somewhere in that range. We are retiring the renewable energy credits from that. So we did not do, sometimes people will sell renewable energy credits from their rooftops and then buy cheaper renewable energy credits. We didn't do that. We kept the ones that were associated with our project. So we get to claim the full environmental benefit of our project. And so here you see we've taken another small bite out of our pie, a little solar sliver. And that's a helpful step as we continue to try to address how we can take care of all of our carbon emissions here. So another thing that we can really get to and do as we move forward is looking at efficient buildings, especially by bringing in innovation. If you haven't seen the Burwell Center for Career Achievement, I'd highly encourage you to take a walk through it. This has become our most efficient building on campus. It's also super exciting, and I could geek out about it for days, but I will spare you some of that and allow Lynn to get into some of the details. You may have noticed that we built 3 new buildings over the last several years. These were the Denver Advantage projects. This is a challenge in one key way. As we build these buildings and add square footage, we're adding almost 286,000 gross square footage of building with these projects. Our carbon footprint is total. It's not a % reduction or anything we're looking at. We're looking at all of the emissions that we produce on campus. So the more we build buildings, it's likely that we're going to use more electricity. We're going to use more natural gas or other heating types. So it increases our carbon footprint typically if we're adding buildings, unless we're really smart about it and we do efficient things at the beginning. So the Burwell Center allowed us to trial some new things that we haven't done on campus before, and actually that haven't been done in the region very much. So we built this as our first mass timber building. So as you saw it going up, I know some people referred to it as our IKEA building. It seemed to click together in place like an IKEA piece of furniture. That was the mass timber coming in, and we'll talk about why that's beneficial. But it allowed us to build a building that's very efficient and build it on time. We've added solar to it as well as part of our other project. And what that's leading to is this being our first LEED Platinum building. That's our goal. We're moving towards that. We brought some funding from our Green Fund, which funds energy efficiency projects, to meet that goal of LEED Platinum. We'll let you know when we get the paperwork back. We'll have a party at Burwell. Hopefully we'll all have vaccines by then as well. So a couple of things that we did, just to point out here, we've got this is what the mass timber looked like. You can see these are structural, it's structurally built out of wood and not concrete and iron. This wood is basically glue laminated together to make it super strong. And it's mostly assembled off-site into large pieces that can then be pieced together once it gets to campus. This speeds the process of building. As you speed the process, you can reduce the labor cost. So it actually it helps balance out the cost of a more efficient building, which typically is associated with adding costs. This also reduces the total embodied carbon in the building, this is a renewable source of building material, whereas concrete and steel are not. So this is how these pieces were. They were glue laminated together to create beams, to create floors. So as you walk throughout this building, you'll see all that wood exposed in many places. But that's structural. That's holding the building up. Even the surround of the elevator shaft is made out of wood. So pretty unique structure. We'll see more of this around the region, I think, as we go. So here you see the prefabricated components coming in. They're precision fit. There's not a lot of waste here, especially not in the field, because there's not cutting happening. It just all comes together on site. So it leads to a lot of efficiencies as it's built. So we looked at a lot of things as we did the design of this building and integrated quite a few of them. And we can see some initial goals here were to build a different type of building. And we quickly moved from these initial goals to more aspirational goals of looking at, could this actually be a net zero building? Could we get to LEED Platinum under this new version 4? And might we even be able to build a building that's certified as a well building, meaning it's been certified to have benefits to the people that work and play in it. Not to say that our other buildings are sick buildings. This is just specifically designed for and would be certified for some of the ways it's operated. So we got to some of these final goals on our design, and we really evaluated all types of things for this. I was really excited to see us even look at compostable toilets for a while. Probably better that we didn't go that route. But here you see in green the things that were incorporated into the building. We incorporated almost everything that was initially looked at as a sustainable strategy. And we'll get into the details on these as we go as to what makes this a very efficient building. And so here you see all those designs combined led us to some pretty impressive reductions over a typical building of this size. So 54% total building energy reduction. We see 22% savings from our solar. We've got the indoor water reduction based on some of the things that we put in the building. So it really came out to be a successful building design challenge. I'm going to turn it over here to Lynn to talk through some of the details.
Okay, so this overview of the building kind of shows you all of the different sustainability features that were implemented there. And as Chad mentioned, it's a great building to take a tour of. And once we get back to some type of normalcy, that's one thing that we'll be providing to highlight some of these things. From a landscape standpoint, and really all of these features gave us significant points in working toward LEED Platinum as well. But from a landscape standpoint, we have the ability to capture stormwater runoff and basically in a way treat that water before it's released as well. Chad touched on the mass timber construction. Bottom right of our slide here is really gives you an idea of what was accomplished by that type of construction with the reduction of cars on the road, as well as how many energy to operate 61 homes a year. Just with this construction alone, that would be the equivalent savings there. What I like to think of with this building is it really takes advantage of our excellent climate here in Denver, as well as our number of sunny days. So we have a building that takes advantage of that from a ventilation standpoint, from a cooling standpoint. And that's really what this graphic shows here. We have the ability to have an open office space areas, utilize daylighting and ventilation as the outside climate warrants. We have operable windows throughout the building. If you think about it, many of our buildings on campus, we cannot operate the windows. We're really limited in the control and the flexibility we have in providing comfort to those buildings. So this is really, it's a simple concept, obviously, but it's one that's very valuable to the building. Solar, we actually designed this building before solar was even considered for the structure, but it was set up to accommodate that. And the solar on this building, not only do we have the solar that's tied to the roof structure itself, but we have panels that you cannot see that just lay on the rooftop on the flat section. Most of our solar across campus, the majority of it is just, it's ballasted, meaning it's just weighted down on flat roofs. They're not visible from the ground, but this will be a case where the Burwell Center, as you can see here, will be visible, and we'll highlight our solar project as well. So when we talk about lighting, we have state-of-the-art lighting controls in the building. These lights will be able to take advantage of daylighting, will be able to dim themselves if the sun is at the angle and at the intensity that's required. We have occupancy and vacancy sensors throughout. So lights will shut off automatically in buildings. We have CO2 sensors as well that can determine the number of people in the room. We'll get into that in a second with ventilation. And even the receptacles. We have receptacles that if they do not sense someone in the office or in the area, those receptacles will actually be de-energized also. Task lighting is really the feature for the lighting. Our ambient lighting in the space is not that intensive, so we're well below code with the ambient lighting, but we're really focused on task lighting for individual workstations in the area. And as you can see here, our overall lighting reduction in the building was 42% versus a standard building that would simply meet the code requirements. Low flow fixtures throughout the building. All of the plumbing fixtures are very low flow. As you can see here, savings in water is 46% on an annual basis. So one of the things when we first started early on with the design, this building did have electric and natural gas for the building, but we quickly made a decision to make it an all-electric building. And as we pointed out, going that route, ultimately when our Scope 2 emissions drop, when Xcel Energy reaches carbon neutrality as well, then our scope will drop to zero also. But originally we had natural gas hot water heaters. We replaced those with heat pumps that actually utilize the heat that's generated in the IT rooms and the IT closets we actually use that to supplement the heating and heat the water. So it is an extremely efficient way to provide domestic hot water to the building. One of the other features when we get into the HVAC, the heating, ventilating, and air conditioning, is we have evaporative cooling with heat recovery on the roof. This allows us to use outside air, and really during the shoulder months, fall and spring, we can basically provide free cooling to the space and to the building. Also, with the reheat capabilities, we can preheat the incoming air, we can pre-cool the air coming in, and it's an incredibly efficient system for the building. It's if you're familiar with swamp coolers, it's basically a glorified swamp cooler to provide us free cooling throughout. Within the building itself, we have what's called a variable refrigerant volume system. We have fan coil units all through the building, but this system allows us to provide heating and cooling to the space simultaneously. So many of our buildings on campus, most of our buildings on campus, we're either in cooling mode or we're in heating mode, depending on the season. But in this scenario, with this particular system, one zone could be in heating mode, another zone could be in cooling mode, all at the same time. Additionally, we can take advantage of adjacent heating areas or zones, I should say, and get some super high efficiencies from each of those. Indoor air quality and energy savings. I mentioned this a little bit earlier, but we actually have carbon dioxide sensors throughout the building, which will change the ventilation amounts to the space. So if a room is not occupied, the ventilation will be minimal. As more individuals go into those spaces, we will increase the ventilation to provide an improvement on the indoor air quality for that space. So just in summary, if we look at all of our different components, you can see the energy use intensity, or EUI. That's the standard used to consider how much energy use we have on a per square footage basis. Baseline or standard or a building meted code would be at 73.5. Our building here is half that. So we're only at 33.6 for an EUI. That's a 42% reduction from a standard building. If we include the solar, the photovoltaic, which contributes about 22% toward the energy, then our reduction is 54% from a standard building. So it's an incredibly efficient building, to say the least. So resiliency and design, just to kind of recap as a summary and talk about resilience. Ultra low energy usage, the envelope is very high performance. We have passive ventilation. We're able to utilize the outside climate the majority of the year. Water conservation is excellent. And then the other thing we've done with this building, because the building is fully electrified, we have the ability, we put in the connections, we have the ability to bring in a temporary backup generator should we have any utility issues where we could fully power the building and basically continue to operate the building. Decoupled ventilation. We have the ability with this building to not only use outside air, free cooling, but also with the system within the building, we can use it simultaneously and mechanically provide cooling and heating to the space. So I think of this building as not only using the outside climate, but it's fully, we have total control of the building from a temperature standpoint, from a ventilation standpoint. Not only is it efficient, but it will provide a very comfortable environment to the occupants. So a healthy building. We've made a lot of changes across campus in this pandemic age that we're in. Changes to ventilation, filters, all of those things to accommodate this new world we're living in. So with this building, we didn't actually have to make any changes that weren't included in the design. So minimum efficiency reporting value, you probably know that more as MERV as the acronym. So the building already have MERV 13 filters, which do filter out the coronavirus. The outside air, we can bring 100% outside air into the space. We have operable windows, which is ideal as well, daylighting and cleanable surface. Flexible architecture, kind of like the picture you see here. All the furniture can be rearranged to keep that 6-foot distance. So basically, this building, the Burwell Center, was COVID ready, I will say. We didn't realize it maybe at the time, but all the features are in place to make it a very healthy building and something that we can continue to operate during this pandemic. I'm going to switch now to some efforts that we've had outdoors here on campus. Again, this will help our Scope 2 emissions. We just completed a campus lighting study. We did this study really focused on safety on campus, but the results are also going to allow us to make some adjustments. We have areas where we can replace lighting, existing high pressure sodium lighting with LED lighting. We actually have many areas, parking lots, parking structures, many areas that are overlit where we can make reductions there. And then, so overall, we're going to be able to lower our electrical consumption and make the campus safer moving forward. So another area where our Scope 2 emissions will be dropped. We have lots of uplighting here on campus as well, and we'll make an effort to adjust and modify those fixtures so that all the light is directed down, improving our night sky as well. But all in all, it's going to be make up for a more efficient exterior lighting across campus.
Thanks, Lynn. So if we're following along, Scope 1, we've gone through. We're going to look at electrification, reduce our natural gas usage. Scope 2, we're building efficient buildings. We're using renewable energy. We're going to get now into Scope 3 and talk about some things that tend to be a little bit more challenging. And as we go through this section, we'll be looking at a couple things we learned during COVID and how that might affect us moving forward. And we'll get into some of the other ways that we can take bites out of this pie. So just to show that, I mean, we've really been examining this, and I think facilities management and planning deserves a huge shout out. You can see here, this is a lot of work that's been going on. We've been building buildings and putting on solar in the middle of dealing with COVID, in the middle of like trying to track all the changes associated with COVID and make sure our buildings are safe and ready. So hopefully this presentation helps you see that there's been a whole lot going on. I think it's hard to overstate the amount of work that's being done by facilities as we look at dealing with COVID and looking at these carbon emission projects. So we've been tracking the reductions in energy consumption and some of the changes around our waste use during COVID. And so we've seen these decreased costs, as you might expect, as there weren't many people on campus, especially at the end of the fiscal year ending in June of 2020. So we saw these reductions in electric, natural gas, water, gave us some ideas of, what happens when you really close down a campus, what sort of savings can we see? It also is interesting to note that we have a green fund that's usually going towards carbon emission reduction projects. That fund was actually also doubles as a utility reserve fund. And so that fund paid all the utility bills. So it allowed some cost relief there for budget concerns across the rest of campus. When we look at our total waste production, you can see as soon as we left campus or went into the COVID shutdown, our waste production dropped dramatically, as you might expect. We know this won't continue, but it gives us some ideas of how we might look at increasing recycling, reducing total waste production. We know we can be 100% paper free now. You know, there's different things that we can learn from this. So if we look at the rest of this pie and how do we get there, we see that we've got a large amount of scope 3 emissions that we need to address. Scope 1, this is our remaining, you know, mostly our natural gas usage, but there's a few different things that we think we can do. One is we know that this work from home scenario has opened our eyes to how that might work in the future. And while some of that's still playing out policy wise, I think we might be able to conservatively estimate that about we could reduce our employee commuting about 25% around potential future work from home options. We have a program going and we're going to continue to, there will be more education about this coming, but we have a current opt-in program for study abroad. Study abroad contributes a large amount of our carbon footprint because we pay for a lot of those trips as university funded travel. So if we can move that to 100% offset, we take another big chunk out of the pie. And that I think is a commitment from sort of all of us and students traveling as well to make that offset happen. Recently, USG has committed through the Sustainability Committee some of the sustainability funds to look at offsets as well. So that could take another chunk out of our pie applied to our scope 3. Remember, we have Xcel Energy on our side in this planning, which is really nice to have. Not all utilities are this way or are advanced as advanced in their renewable goals. Xcel Energy is saying they'll be carbon neutral by 2050. If we hold them to that, all of our electrical footprint goes away. So that just leaves us with these two little pieces of the pie. That's about 38% that's remaining from where we are today. And so really when we get to this point, that's when we start talking about, are there additional things that we can do around travel? But really a lot of the conversation then needs to become, is it more effective to electrify our buildings? Or are we looking at buying a lot of carbon offsets, which are basically paying for the construction of new projects that will absorb carbon in some way. It might be forestry projects or grassland projects, methane capture projects. But it's a way for us to say, we're emitting this much, but we're going to contribute to projects that are going to catch this much carbon. And that might be something we look at. So I know some of you are sitting here thinking, but I've already heard universities saying they're carbon neutral. How do they do that? How are they already there? So I wanted to take a brief minute or two to look at a couple of university case studies and just show us a few things that might inform our decision making going forward. So I will note, first of all, that a lot of what we're seeing initially is small schools. And small schools have small carbon footprints. If you only have 1,000 students instead of 12 or 13,000 students on campus, that's a big difference in the amount of total carbon put out. So you have a smaller carbon footprint. And a lot of these schools, the smaller schools that have gone carbon neutral already, are well funded. And so they have funding to do carbon offsets. But you could see, for instance, Colgate here has put out a couple press releases about them getting to carbon neutrality. They're a small school. They actually have installed a biomass boiler. So they're using wood chips to feed into, they burn them on campus to produce the steam or hot water like Lynn was talking about for 14 buildings. DU is not going to be able to, we're not going to have a wood burner at any time soon. But you can see here what they've done. This is your total scope 2 emissions. So when they claimed carbon neutrality in 2019, their scope 2, that's their electricity, was they had reduced that to 0. If you look at their net emissions, they've done a good job, and they sort of went up and down, but they did a good job in reducing those fairly significantly. But overall, their gross emissions that they were emitting have kept going up. So really what you see here is they have purchased carbon offsets locally and internationally based on what their goals they're looking at in order to get to being able to claim carbon neutrality. But really they're carbon neutral in scope 2. Might take another case study. American University, which is more a peer of ours in terms of size and being in an urban setting. They've done some work. They've announced carbon neutrality recently. And you can see they've reduced their electrical use per square foot through doing different technologies. And we could claim, hey, we've reduced our total carbon footprint, I mean, by 26%. So we're right there in this ballpark. In 2011, they went to buying 100% renewable credits. So that's where you see this is their scope 2. They started buying renewable credits. So basically they bought their way to carbon neutrality, which is one approach that universities take. They've then gone in and continue to work at renewables and ways that they can provide electricity in partnership with bigger projects and other big institutions in the area. And then they went with, you can see here, our total gross emissions are lowering, and they did a good job of getting down under 50% reduction of their gross emissions. And you see their net emissions were tracking right along with that because they'd gone to neutral on electricity because they bought those credits. And right around 2017 and 18, they bought a bunch of more credits. That's why you see, or carbon offsets. That's why you see this drop to neutral. So between large purchasing programs in 2011 and 2018, they became carbon neutral by buying RECs and offsets. So that's one way to do it. And it raises a question for us, which is what's the cost of carbon for DU? If you're interested in this, I'd invite you to come talk to me and we can talk about some research projects. But some universities say we're going to buy offsets and that's going to inspire us to create more change, because if we can reduce our natural gas consumption, reduce our electricity, then we'll pay less for offsets. DU's take an approach of saying we're going to keep putting our money into our efficiencies, into reducing our carbon footprints, and at a later point, we know we'll have to buy offsets. So there's trade-offs to approaches, different ways we can go. But that's where we are now. So I hope this has been helpful for you to see how we're approaching our 3 different scopes on campus, our plan for reducing those and getting to a future that is carbon neutral. If you're interested in supporting this, we have, well, one, there's more that you can do. Behaviorally, some studies show that behavior can reduce building energy use by 30% or so. So there are things that you can do in your building. If you are thinking that your building has some efficiency needs or energy savings potential, you're able to, we're looking at ways through Lynn's office and my office to do energy audits with Excel of some of those spaces. We do have some needs, if you're interested in research around this area, of better understanding our campus to look at that scope 1 electrification. And then we'd encourage you to join the Sustainability Council Energy Committee, which is looking at policies, projects to impact our energy consumption on campus, which really gets to the heart of this. So a lot of this work came from work of many partners. We've got some great consultants that have been working on these different buildings, so we'd like to acknowledge them. But at this point, I'm going to stop share, and if there are any questions, I think we have a minute or two, and we'd be glad to take those afterwards as well if others come up. And I thank you for being here. Hopefully this was informative. I know it's a lot of information. We have no time for questions. We've got to roll. So if you do have questions, email Lynn or I. We'd be glad to try to help you out. Hopefully this was informative. I know it was a lot. Thank you for being here. And thank you, Lynn, for all your work.
Very good. Yeah, thanks everyone for participating.